CRISPR-Cas9 is a genome editing tool invented by Dr. Jennifer Doudna. It stands for Clustered Regularly Interspaced Short Palindromic Repeats, or repeating DNA sequences in prokaryotic cells with the unique sequences in between the repeats. The genome editing system involves a Cas9 enzyme and a guide RNA strand. Cas9 is an enzyme that cuts up the DNA, and it is guided by the RNA. Once the system is inserted into its target, the RNA strand finds a place in the genome where it is complementary to the DNA strand. The Cas9 then cuts up the DNA, and the RNA strand binds to the DNA. This triggers DNA repairing and eventually results in mutated DNA with the desired sequence. The CRISPR system is derived from a similar system used by ancient prokaryotic bacteria. These bacteria were attacked by viruses, and they used the CRISPR system as an immune response, which allows them to find and eliminate the viral genetic material. When attacked by viruses, some bacteria survive, and those that do keep the viral DNA as protection. And so, when the virus attacks again, the CRISPR system transcribes the DNA into RNA and joins with the Cas9 enzyme. Now, the enzyme finds all DNA sequences that match the guide RNA and cut it up, preventing the viruses from reproducing and essentially protecting the bacteria. Currently, CRISPR is an easy, cheap, and effective way of gene editing, and is thus seen as one of the most prospective methods for editing. The technology has made much progress. It has been tested on various animals as well as in viable human embryos, and the results look very positive for the future. CRISPR has even been used to change an entire species and create animal chimeras, which are organisms with cells from two or more distinct genetic populations. While such successes show hope for the future, CRISPR needs to go through much more development before it is ready for human use. One issue with the system is that DNA must be damaged before the guide RNA becomes part of the genome, and such damage may lead to catastrophic effects. Also, it is not 100% accurate, as the Cas9 enzyme sometimes makes unwanted cuts and causes damage. On top of that, the Cas9 enzyme stays inside the cell after its job is done, and that risks it becoming dysfunctional and making cuts in the DNA that it is not supposed to. Even with its issues, CRISPR holds much potential for the future, both good and bad. It could possibly cure every genetic disorder, even cancer. It could bring back extinct species. It could end world hunger and provide donor organs through animal chimeras. Also, it could save the world billions and trillions of dollars once spent on medical research and use that money to help in a different way. However, with such possibility for good, there is possibility for the bad as well. The major fear for the future is designer babies, or babies that have had their genetic makeup predetermined, with desirable traits added and undesirable traits removed. In this way, people's gender, skin color, weight, hair color, and other traits can all be determined before they are born. Many see this as a realization of eugenics and possibly the creation of the Aryan race. According to utilitarianism, CRISPR is ethical. It holds the potential for curing countless genetic diseases and ending world hunger. Only when considering cancer, CRISPR can save and benefit the lives of at least 13 million people a year. Moreover, because of its simplicity, it is cheap, making it available to most, if not all, members of society, and resulting in the greatest good for the greatest amount of people. On the other hand, according to obligation, CRISPR is unethical, especially because of the possibility of designer babies, as it fails the categorical imperative. One aspect of the categorical imperative is to universalize one's maxim, which entails treating all people equally. However, by changing a person's traits before they are born, an inherent inequality exists. A preference is shown for certain traits over others, and thus the modified human is seen as superior to the original one. CRISPR is also unethical according to Catholic social teaching. In Catholic social teaching, all human life is sacred, and by editing embryos, that sacredness is desecrated. In fact, the teaching specifically states that the value of human life is threatened by embryonic research. Also, by changing a person's trait before they are born, people are taking the role of God into their own hands, making CRISPR unethical in that aspect as well. I believe that CRISPR holds too much potential for good to be stopped. It is a cheap and simple method, and its applications in medicine are innumerable. It can have such beneficial impacts, and for me, if its potential for good is realized, it will be the greatest invention in the history of the world. It seems that embryo editing is the main issue with the technology, and so I feel that a solution would be calling a moratorium or temporary stop on embryo editing and research through CRISPR technology. This moratorium will give the science community a chance to establish guidelines and restrictions with embryo editing and allow for other CRISPR research to continue, resulting in a fair compromise.